a small example to illustrate how MapReduce works using Hadoop. I'm going to get data from the city of Chicago. These are payments that different departments of the city had made for a long time now, since I believe 1986 or so. It's about 737,000 records. Of course, this is not big data, but it's a lot of data. And it's a flat file, comma-separated values, where the first column is the voucher number, the second column is the amount of the money, then the check date, then the department name, and then the contract number, and finally the vendor's name. Those are the columns. So for example, here we have a record. I'm going to use this one. Here we have a record, the last record, right, where this is the voucher number. The amount was $255.58. The check date is December 28th of 2016. There was no department name. The contract number says DV, and the vendor name is MedRisk Inc. There are many points of missing data. Some vouchers are missing as well. We're not going to care too much about that. We're going to work with dirty data just for this example. We're not going to clean it up. Now, what I will try and get is the amount spent by department name. Okay, that's the summary that I need. I will assume that you have installed Hadoop. If not, you can get it at the Apache Foundation. For simplicity, all the code and data will reside in the same directory or folder. So I'm not going to assume that there's a file in a different cluster, in a different computer or a node, and so on and so forth. And I will not use an ID for compilation. I'm going to use the command line. I just want to illustrate the bare bones. And this is how it goes. Remember, our MapReduce process goes like this. We get an input, which by default in Hadoop, the key for a flat file, the key is the line number, and the value is the contents of the line, right? I'm going to get that, I'm going to map that, and I'm going to map that into where the key is going to be the department name, and the value is going to be a list of the amount spent on that. Okay. Then I'm going to reduce that, which means for each of these values, I'm just going to add them. So let's look at the mapper class. So in Java, what I'm going to do is, after all the important imports here to actually work with this, I'm going to create a public class payment mapper. We'll extend mapper, and this signature is interesting because I'm going to extend mapper long writable text. This is the input. Long, it's a long number, that's a line number, and then text is the whole line. That's how the data comes. That's the first map that I get as input, is a map where the keys are numbers and the values are just text. And what I'm going to produce is text, because that's the department name is text, and an amount, a dollar amount, and a dollar amount is double, so I use the class double writable. So you have long writable, double writable, and all the different types of numbers writable. There's a lot of Java types and then the word writable next to them for Hadoop. I will create two variables here, two private variables. One's going to be a word, which is going to be of type string or text, and the other one is going to be the count, or the dollar amounts, right? Which is going to be a double writable. Now, I have an I equals 0. Forget about that for now. That's legacy counter from a different method. Now, the main method here that I have to override is the method map. Now, this might change in the future. The signatures of these methods or not might be deprecated soon, but it doesn't matter. Just adopt the method that's currently available. But the method map will take a key of the type of the input type keys, a value of the input type values, and then a context. Context is where you're going to actually put the output. That's always context. So you only have to worry about these two parameters here, that they're the right type for the input. Then has to throw an exception. So when you overwrite, you'll see that. Now, remember, these are the columns of my file. So what's going to happen is I'm going to get the key, right, which is the line number, and then I'm going to get as value the actual contents of the line. What I'm going to do is every time I get a line, a value, I will convert it, I will separate it into an array, split by commas. So what this does is it takes a line, it takes the commas out, and every element in between commas will become an element of the array. And I will store it into this array called split. Now, what I'm interested in is the department name. That is the third index of the split. So if you see here the columns, 0 is voucher, 1 is amount, 2 is date, 3 is department name. So I'm going to set the word, the key basically, to be the department name. Now, if the split dot length is greater than 2, basically if I have more values, right? So I should have used this verification before this. But if the length is greater than 2, basically if there's a valid line here, right? What I'm going to do is I'm going to try and set the following. I will get split 1, so the second value, which is, if you see here, the voucher is the amount. I'm going to skip the $sign, so I'm going to substring it from index 1 onwards, right? So I'll effectively skip the $sign that I saw in the text file. And this will become the actual dollar amount. That dollar amount, I'm going to turn it into a double number and then set it as part of the count. And then here, this context, this is a map. And I'm going to write the key, which is going to be my word, and the count, which is going to be my dollar amount. And if I write more dollar amounts with the same word for the same department, it will just add it to a list. And that's all I do with the mapper. There's nothing else. Basically, I just have to take care of this method map, mapping the input, and then put it in a context, which is going to be a map with key value pairs. That's all I have to do. This is the mapper. Now, the reducer. For the reducer, what I'm going to do, this is the reducer. I created this double sum reducer, which is the reducer. And here, for the reducer, it's going to be a reducer with some key and double writable. Okay, that's the double. It's going to reduce the list to double. So I get a private variable called result, and then I override the reduce method. Okay, the reduce method. In the reduce method, I get the iterable of whatever writable values I want to reduce and the context. And this is very simple. I just have a sum, which is double, and then for each value in the set of values that I get, which are here, for each value of the corresponding to a given key, I'm going to just add the sum. I'm going to just get these values. Then I'm going to set the result to the sum. This is the actual reduced result. I'll set it to the sum, and then I'll write the key that I have, which is going to be whatever key I had before, and then the result, effectively summing over all the values. That's all. So I have a map and a reducer. The last piece is how do I glue them together and tell Hadoop to execute these things. I do that with a job. So the job will call MapReduce with the mapper and the reducer. This is pretty standard here. I just didn't put all the imports because it would be a very long listing. But assume all the imports are here. What you do is you create a class that extends, configure it, and implements the tool interface. I called it payments job. What will happen here is you have a method called run. This is not the main method, but it's the heart of the job. There's a set of where you just set the job, get a configuration default for Hadoop. You get the classes via a jar file. We're going to explain how that works, and then we're going to set the job name, and in this case I just set it to the class's name. Now, just so it's payments job. Now, in the command line, when you execute this program, you're going to provide a path for the input file and the output path. So I have just formats, and I add the input and the output, and it's going to be the argument 0 and arguments 1 from the command line. Then here's the other thing. I'm going to say the mapper class is payments mapper. The combiner and reducer class are the same, double sum reducer. And then for the output keys, they're going to be text, and the output values are going to be double writable. So I just tell it what class these things are going to be, and I just do this return job dot wait for completion true, and that's that basically gives me a 0 if it's successful, 1 if it's not. And then my main method, which is what I'm going to execute here, my main method basically says create toolrunner.run with a new payments job with this class and the arguments that you got from the command line here. And then just finish and exit with this code that was returned from the previous method. That's all. So let's see how this works. What I'm going to do first is I'm going to compile these things. I'm going to copy and paste the commands here. I'm going to you see Java C class path. For the class path, I'm going to use this little syntax. Basically, if you install Hadoop, you have Hadoop home set. So this Hadoop home bin Hadoop, that's where the Hadoop command is, and then class path is going to give me all the class paths that I need from Hadoop. Colon period, which means this folder as well will be in the class path, and then the payments job Java, the main class. I will compile this, and then there's some deprecation here. I'll have to update that. Then after that, what you want to do is jar these class files. Why? Because when it's distributed, this jar gets distributed to every node, so every node can do the same mapping. So I'm going to here get the jar file. I'm going to jar these files. So jar CVF. I'm going to call it payments jar, all the payment classes, and the double sum class that I created. By the way, the double sum reducer is actually a default class, and it does exactly what I'm doing with my class here. So it was there, and then now the other thing that I have to do is call Hadoop, and here's what I'm going to call it. So here's my path to Hadoop. You can have it in your path, and you can just say Hadoop. I'm going to use a jar called payments.jar, and the input file is going to be the job that I'm going to execute is payments job. The file that I'm going to process is payments.csv, and I'm going to put everything in an out directory. So I just run this and execute it. And once it's done, I will see this is processing 737,000 files or something, records or something. And when it's done, I'll get all the input. Mostly this is the first thing you check, the number of bytes read and written, so it actually did something. And then if we go to out, you will see a file called, in my case, part R something something, right? And I'm going to just display the first few lines of part R 000. And as you can see, I get a department name and a dollar amount, a department name and a dollar amount, and so on and so forth. So every department with their numbers, and because they're doubles, I get like e to the 7th, right? So this is basically move the period 7 spaces over to the right, and so on and so forth. But that is the basic principle of Hadoop and MapReduce.